Hello, good morning everyone. My name is VIDHYA SAGAR. Now we are going to discuss about the P block elements. In the P block elements, today class, now we are going to discuss preparation of dinitrogen. We are going to discuss now. Okay. Preparation of dinitrogen gas. Okay. Dinitrogen gas in the atmosphere, 78% is present. This 78% of dinitrogen, they will liquefy and after they will do distillation. Liquefaction and distillation process, they will prepare their dinitrogen industrial level. Okay. In the laboratory, the dinitrogen is prepared by, that is ammonium chloride is a reaction with the sodium nitrite NaNO2. Then ultimately you will get N2 gas, okay, plus NaCl plus 2 moles of H2O will be formed. N2 nitrogen N2 NaCl, okay, and 4 hydrogen 2 oxygen 2 moles of water molecule will get. So this is the preparation of dinitrogen in the laboratory. Okay, right. And dinitrogen, another one preparation we can prepare by decomposition of ammonium dichromate. Decomposition of ammonium dichromate. NH4 taken to Cr2 ammonium dichromate. Cr2O7. Decomposition of ammonium dichromate also we can prepare with dinitrogen. Here N2 gas it will be formed. Then after that Cr2O3. Okay. And the next you see here 4 to the 8 hydrogen. Then we write as a 4 moles of water molecule will be formed. So decomposition of dinitrogen it will be formed by ammonium dichromate. What is this? You know? This is ammonium dichromate. Okay. And the next very pure dinitrogen. We can prepare by barium azide. Okay, Ba3M2 barium azide 2 moles. Barium azide. Ba taken 3. Ba N3 taken. This is the barium azide. Ba3 taken 2 is reaction with then formation of Ba plus 3N2. It's a barium azide. So here they are very pure dinitrogen will be found. Very pure dinitrogen in this process. And from sodium azide also we can prepare Na3M2 2 Na3M. Sodium azide. In the sodium azide, 2 Na plus 3 and 2 Na. In this process also we can prepare very pure dinitrogen. Very pure dinitrogen is found. Okay. Now see. Preparation of dinitrogen. Ammonium chloride is reaction with NaNO2 then formation of N2. And decomposition of ammonium dichloride, also we can preparation of the N2. And in this process, from these two compounds, we are going to prepare the pure dinitrogen, BaN3 taken 2 or any N3. So here Ba plus 3N2, very pure dinitrogen we can prepare by this process. Okay, right. And the next you see, preparation of. Now we are going to discuss about the dinitrogen is a colorless, odorless gas. Colorless, odorless gas. And which is insoluble in, means less soluble in water, which is less soluble in water. Less soluble in water. Okay. And dinitrogen is inert at room temperature. Dinitrogen is inert at room temperature. Inert at room temperature. Dinitrogen is inert at room temperature. It does not react. Why? Because you know that nitrogen to nitrogen, to break the triple bond, and in the last class we discussed that 941.4 kilojoules or more. Okay, so dinitrogen bond dissociation enthalpies are very high. So that's why at room temperature does not react to dinitrogen. But it is a reaction with highly reactive elements like dinitrogen reaction with the highly reactive elements like lithium, Li, N2, 6 Li, then 3 moles of Li, 3N, 2 moles of, see, 6 moles of Li plus N2, 2 Li, 3N, it will be formed. And this reaction with the magnesium also, Mg plus N2, then formation of Mg3N2 also it will be formed, Mg3N2. Why? Because these are highly reactive metals. These highly reactive metals reaction to dinitrogen, then formation of lithium nitride as well as magnesium nitride. Okay, and this dinitrogen is combined with hydrogen also, then forms ammonia. Ammonia it will be formed. N2 plus 3H2 equilibrium 2NH3 it will be formed. Ammonia it will be formed. Ammonia, which is combined with hydrogen also. And this dinitrogen reaction with O2 with a high temperature, that is about 2000 Kelvin temperature, which is formation of nitrogen monoxide. Nitrogen monoxide. So these are the chemical properties of the dinitrogen chemical properties. Okay, and see what are the uses of this dinitrogen? Uses, how they will use. Okay, uses of dinitrogen. Dinitrogen, which is used to preparation of the urea as well as ammonia. Which is used to preparation of urea as well as ammonia. And see, this dinitrogen to create the inert atmosphere. To create inert atmosphere. Okay, where in metallurgy, like in the preparation of metals like iron and steel industry, to preparation iron and steel, it is act as inert atmosphere, create the inert atmosphere. Okay, and dinitrogen, it is used as a refrigerant. Okay, to preservative the biological chemicals. Biological specimens as well as food also. Food also. Okay, and the very important point, this dinitrogen used to cryosurgery. What is that, cryosurgery. This is a very, very important point. Dinitrogen is used to cryosurgery. So these are the some uses of dinitrogen. Okay, now we are going to discuss the second compound, that is ammonia. Yeah. Now we are going to discuss about the second compound, is that ammonia, NH3. Sir, ammonia, how can we prepare? Ammonia we can prepare from urea. Urea formula, the first one is that NH2 C11O NH2. This is the urea. Urea reaction with water, then formation of ammonium carbonate NH4 taken to CO3 will be from ammonium carbonate. This ammonium carbonate further decomposed, then formation of 2 moles of ammonia plus water plus carbon dioxide gas will be released. So here ammonia it will be formed. Ammonia is formed. Okay, this is a preparation one. And the second preparation, ammonia we can prepare from ammonium chloride. NH4Cl, ammonium chloride. Ammonium chloride is a reaction with the calcium hydroxide CaOH taken to calcium hydroxide. Then formation of 2 moles of ammonia plus CaCl2 calcium chloride plus 2 moles of water molecule will be formed. So this is the preparation of ammonia from ammonium chloride. And the third preparation is that ammonium sulfate, NH4 taken to SO4, ammonium sulfate is a reaction with the 2 moles of sodium hydroxide, ammonium sulfate. Okay, then formation of 2 moles of ammonia plus Na2SO4 plus 2 moles of water molecule will be formed. So by these 3 methods we are preparing ammonia. Industrial level, by the Haber process, how can they prepare? How they will prepare? Haber process. Okay. Fourth one, preparation of ammonia by Haber process. By Haber process. Haber process, how they will prepare? M2 plus 3H2. M2 plus 3H2 equilibrium 2 moles of NH3 will be formed. The delta H is equal to 41.6 kilojoule per amount of heat is released. Okay, so delta H is equal to minus 41.6 kilojoule heat is released. Means this reaction is the exothermic reaction. In this reaction, some amount of heat is released. Okay, and the important point to see, according to Le principle. According to Le principle, here you see N2 and 3H2 is 1 mole plus 3 mole, 1 plus 3 total 4 moles. 1 plus 3, 4 moles is converted into the 2 moles. See, just to understand here, 4 moles converted into the 2 moles means we want to apply the large amount of pressure according to Le principle. According to Le principle, we want to apply the large amount of pressure. The amount of pressure is required. The amount of pressure is required here 200 atmosphere pressure. I mean high pressure is required here, high pressure. And you see, in this reaction, delta H is equal to negative. Delta H is equal to negative. It means that what happens, exothermic reaction. In this reaction, heat is released. So according to reaction, low temperature is required. The low temperature, how much low temperature is required. 700 Kelvin temperature is required. 700 Kelvin temperature. Okay. In catalyst also required. Catalyst in the Haber process, iron oxide. What is that? Iron oxide. Okay, nowadays they are using instead of iron oxide, aluminum oxide or potassium oxide also they are using as a catalyst. Then also the reactions are very slow. So that's why they are going to take that is a promoter. What is that? Promoter they are going to take. This promoter they will use molybdenum, molybdenum. Molybdenum will be used as a promoter. Sir, what is the meaning of promoter, sir? Yeah, actually, catalysts enhance the activity of the catalyst is said to be promoter. It means that catalyst, if it is not work properly, then promoter it is increase the enhance the activity of the catalyst, that is said to be promoter. Here, promoter is a molybdenum. So by these three, by these are the optimum conditions to preparation of the ammonia. By which process? By Haber process. By Haber process, we are going to prepare the ammonia. Okay, and then the important point here you see, here whatever the ammonia is formed, okay, liquid ammonia it will be formed. This is a liquid ammonia. Liquid ammonia it will be formed. This liquid ammonia is dried by not H2SO4. You remember that is important point. We cannot dry it by the H2SO4. H2SO4 is a dehydrating agent. Ammonia has some amount of water molecules that is not dried by H2SO4. Why? Because ammonia is a Lewis base. H2SO4 is acid. Both are reacts, then formation of ammonium sulfate. You won't get ammonia. Then how, sir? How can I remove the water molecule from ammonia? You can remove it by the compound CaO, calcium oxide only you can remove. By calcium oxide, by using quicklime. By using quicklime also you can remove the water molecule from the ammonia. So these are the preparations of ammonia. Okay, now we are going to discuss about the properties of ammonia. Properties of ammonia. Ammonia is a colorless gas with a pungent odor. Ammonia is a colorless gas. Colorless gas with a pungent odor. Pungent odor. Ammonia is a colorless gas with a pungent odor. And see here, this ammonia having the melting point as well as boiling point is very high. Yesterday we discussed the point is that in the fifth group elements, boiling point order, first pH3 greater than arsenic H3, then after ammonia, nitrogen, phosphorus, arsenic, then after antimony, then after bismuth. This is the boiling point order of this. It means that ammonia boiling point is higher than phosphide as well as arsenide. Okay, so why, sir? You remember the important point. In the liquid state or in solid state, ammonia forms, what is it, intermolecular hydrogen bond. Ammonia forms, what is it? Intermolecular hydrogen bond. Intermolecular hydrogen bond. Due to the association of the intermolecular hydrogen bond, the boiling point of ammonia is very high, very high. Okay, and this ammonia, it has pyramidal shape, trigonal pyramidal shape, pyramidal shape, pyramidal. Okay, so now the shape is that ammonia shape like this. It's a pyramidal shape having one lone pair of electron. And ammonia, which is having sp3 hybridization. Which hybridization? Ammonia forms sp3 hybridization. sp3 hybridization. And the important point is that ammonia, which is readily soluble in water, then formation of weakly basic nature. Weakly basic nature. What I mean, ammonia is readily soluble in water. Ammonia is readily soluble in water. Ammonia readily soluble in water. See, ammonia NH3 is reaction with the H2O, then formation of ammonium hydroxide, which is the weakly basic nature, ammonium hydroxide. Okay, this ammonium hydroxide reaction with some metals. Okay, then what it will be formed? Now I am going to take zinc sulfate, is reaction with ammonium hydroxide, then formation of 2 moles, then formation of ammonium sulfate. Ammonium sulfate, it will be formed plus zinc hydroxide will be formed. This is a white PPT. And this ammonia reaction with some acids. Ammonia reaction with some acids. This is acid. Then formation of salt. NH4 is a salt. Not only HCl, ammonia is reaction with sulfuric acid. H2SO4, then formation of ammonium sulfate. NH2SO4 taken 4. Ammonium sulfate. Means that ammonia is going to react with some acids, then formation of salts. Okay, and here ferric chloride FeCl3 is reaction with ammonium hydroxide. Okay, then formation of Fe2O3 XH2O, brown color substance it will be formed. Brown color PPT. Okay, and the very important point to remember: whenever copper ions, Cu plus to copper ions is reaction with ammonia, deep blue color it will be formed. Deep blue color. Then Cu NS3 taken 4 plus 2. This is the deep blue color it will be formed. Deep blue color. Copper is reaction with ammonia, then formation of deep blue color it will be formed. Okay, and you see, AgCl is a white color PPT. AgCl is a white color PPT. That AgCl also reaction with ammonia, the white color is disappear to colorless. Then what it will be formed? AgNH3 taken 2. Cl it will be formed. This is a colorless substance. Okay, so these are the chemical properties of ammonia. Ammonia chemical properties. These are. Okay, and remember, in these chemical properties, the copper reaction with ammonia is a very important for the competitive level. It forms which one? Blue color. Blue color it will be formed. Right, and the next you will see uses of ammonia. Okay. Uses of ammonia. Uses of ammonia. Ammonia, which is used to preparation of the many fertilizers like urea, many fertilizers, and ammonium nitrate, okay, ammonium sulfate, and ammonium phosphate. Okay, especially this ammonia which is used to preparation of nitric acid. Preparation of nitric acid. Ammonia is especially used to preparation of the nitric acid. And ammonia also act as a refrigerant. Ammonia is also act as a refrigerant, and this ammonia used to preparation of the many inorganic compounds. Many inorganic compounds also we can prepare by using the ammonia. Many inorganic compounds also we can prepare using ammonia. And the next you see here, oxides of nitrogen we are going to discuss now. Oxides of nitrogen. See, this is this table is a very important. We are going to discuss about the oxides of nitrogen, oxides of nitrogen. In the oxides of nitrogen, first one is that N2O, then NO, then N2O3, then NO2, then N2O4. The last one is that N2O5. Nitrous oxide. This is nitrous oxide. What is that? Laughing gas. It's a laughing gas formula. NO, nitrogen monoxide. N2O3, nitrogen dinitrogen dioxide. Nitrogen dioxide, dinitrogen tetroxide, dinitrogen pentoxide. These are the oxides of nitrogen. These are oxides oxidation state. Here +1, here +2, here +3, here +4, here also +4, here +4. So these are the oxidation states. So these oxides, how can we prepare? The preparation is also important to see. How can we prepare? These we can prepare by ammonium nitrate NH4NO3 decomposes, then formation of N2O. N2O plus 2 moles of water will be formed. 2 nitrogen plus oxygen, 2 moles, 4 moles. N2O, laughing gas, it will be formed. Okay. And NO gas, how can we prepare, sir? NO gas we can prepare 3 moles of NaNO2 plus 3 moles of S2SO4. Now see here, 3 moles of sodium bisulfate, it will be formed, sodium bisulfate. And here nitric acid HNO3 form plus H2O plus NO gas here. Here it becomes NO. Nitrogen 1, 2, 3, HNO3. Here 2 moles of NO will be found. Oxygen 2, 3, 6, 12, 18. 3 jar. 6 plus 3, 4 jar, 12, 18. Yes. Everything is balanced. So your nitrogen monoxide will be formed by your preparation. Okay, sodium nitrite reaction with the sulfuric acid and formation of nitrogen monoxide. So N2O3, how can we prepare, sir? N2O3. So very easy. NO2 is reaction with NO, nitrogen dioxide, reaction with nitrogen monoxide, then formation of N2O3. That's it. Okay. And NO2, how can we prepare, sir? 2 moles of lead nitrate PbNO3 taken to 2 moles of lead nitrate, which is undergoes decomposition, then formation of 2 PbO plus 4 moles of NO2 plus, okay, and O2 gas will be liberated. So nitrogen dioxide it will be. So nitrogen, see, it's a very simple. 2 moles of NO2 is considered as a N2O4. And the N2O5, how can we prepare, sir? This is important to see. Preparation of NO2 and preparation of N2O5. These two are very important, including this one. First one, this one, and this one. These are very important. So here, how can you prepare? P4O10 phosphorus pentoxide is reaction with 4 moles of nitric acid, then formation of 4 moles of HPO3 plus 2 moles of N2O5. See, nitrogen pentoxide it will be. Nitrogen pentoxide. So these are the preparations. Okay. And now we'll see N2O. You remember N2O on that here. We will say colorless, neutral gas. You remember this code. N2 is a colorless, it's not having the color. And a neutral gas is a gas. Okay. And you see NO. NO also same. CNG. CNG meaning that it's not a compressed natural gas. It is a colorless, neutral gas. Both are colorless neutral gas as well as colorless neutral gas. Okay. And the next N2O3. Yeah, N2O3. This is a blue color acidic solid. What is this? Blue color. Blue color, it has a blue color. They will ask for the competitive. Blue color gas. Sir, N2O3, sir. Blue color gas. And blue color acidic nature, and it's a solid. It's a solid. It's not a gas. Okay. And NO2. NO2 is a brown color. It is a brown color acidic gas. Brown color acidic. This is a gas. Brown color gas. Okay, N2O4 and N2O5, these are colorless, acidic, solid. This is also colorless, acidic, solid. So this is the oxides of nitrogen. Oxides of nitrogen. Okay. In these oxides of nitrogen, you remember the very important point: the laughing gas. Okay. NO and NO2. What is that, NO and NO2, these two gases are paramagnetic substances. Paramagnetic substances. Oxides of nitrogen, which of the following is paramagnetic substances? That was the question. So your answer is that NO, nitrogen monoxide, and nitrogen dioxide. These two are best examples. And another one question they will ask. Nitrogen to nitrogen lowest bond length. Nitrogen to nitrogen lowest bond length that is present in laughing gas. Only 113 picometer only. Nitrogen to nitrogen lowest bond length. Okay. And N bond containing molecule, that is a N2O5. N bond containing which molecule? N bond containing which molecule? Your answer is the N2O5. N2O5, N bond is present. Remaining all oxides, nitrogen to nitrogen direct bond is present. Here nitrogen to nitrogen, here nitrogen to nitrogen. Here also nitrogen to nitrogen direct bond is present. But N bond is present in N2O. Okay, and they will ask, already I told you, blue acidic solid, which of the following is blue acidic solid? So your answer is that N2O3. This is the oxides of nitrogen. Okay, and today we discussed the preparation of dinitrogen and the preparation of ammonia and oxides of dinitrogen. Oxides of nitrogen. We discussed. And the next class we are going to discuss about the preparation of nitric acid. Okay, right? Thank you. Thank you very much. Bye. First class,